Hello, everybody. Let's discuss the Neet paper, which is held today. That is the 2024 paper. Now, the paper was very easy, a little bit tricky in the sense, but we'll see how the questions are. Let's get started. See the first part there. What it says, first of all, the first question there, you have to match with respect to is the thermodynamics question, the isothermal process, isochoric, isobaric, adiabatic. Now, we all know with respect to the process, isothermal process, always at constant temperature, exchange of heat between the system and surroundings. Isochoric process, always at constant volume. Isobaric at constant pressure, and adiabatic, no heat is allowed to enter nor leave the system. So for the first one, if you observe, that's going to be the third option. That's the first one. All right. Next one. Arrange the following elements in the increasing order of their first IE. Now, when you say increasing order, it will be always from lower to higher. So if you see that part, increasing order of first IE, then it's going to be lithium, less than boron, less than beryllium, less than carbon, less than nitrogen. Where beryllium is more as compared to boron, that's as per the stability rule, because beryllium, atomic number 4, has a completely filled orbital over there. Hence, its IE value is higher. Stability rule, half filled, completely filled, and empty orbitals are more stable than incompletely filled orbitals. So the 52nd, that's the first option. Then comes the next. Match the following where it says the number and types of bonds between the two carbon atoms. So between the carbon atoms, what type of bonds are there? So for this, the third one, look at that. Ethane has 1 cc sigma. Ethene has 1 cc sigma and 1 cc pi. That's sp2 hybridized. Ethane was sp3. C2 molecule, if anybody remembers, it's an unstable molecule, always exists as an intermediate in reactions, where C2, as per the MOT, the molecular orbital theory, it has got 2 pi bonds when you write it down as per the MOT part. And last is ethyne, which is made up of nothing but 1 cc sigma and 2 pi. So 53, that's option 2 over there. Then the next question. Henry's constant for the 3 gases are given and the solubility is asked. Now, with respect to solubility and Henry's law, we know the formula. Solubility is Henry's constant into its partial pressure. So as we know, Henry's constant and solubility both are inversely proportional. So we will say lower the Henry's constant, more is the solubility. So 54 is the first option, which is B greater than C greater than A. Then arrange the following elements in the increasing order of electronegativity. Again, increasing order, lower to higher. So here, if you observe, increasing order, normal values, it's option 4, where silicon, that's 1.8, less than carbon, that's 2.5, nitrogen 3.0, oxygen 3.5, and fluorine, that's the highest. Then after nitrogen is oxygen, 3.5, the second most electronegative element. And last maximum is fluorine. We know on the Pauling scale, F has the highest value of 4 units. So 55 is 4. Then the compound that readily undergoes SN1 reaction mechanism, meaning it has to readily form a stable carbocation. So here, if you observe, that's going to be nothing but the third option. Why? Look at this. This compound is a benzylic compound. All right. So that's going to be nothing but, if you check the IUPAC part, this will be nothing but 2-bromo, 2-phenyl ethane. In this 2-bromo, 2-phenyl ethane, now in this benzylic part, it's a benzylic 2 degree. So the carbocation would be stabilized by resonance. Hence, this will readily undergo SN1 mechanism. So 56 is the third one. 57th, which of the following process entropy increases? What's entropy? The randomness of the system. In other words, gaseous state is the most random state of matter. So hence, gaseous state represents the highest entropy. Liquid evaporates to water. Yes, we will say entropy is gonna increase. Entropy represented by S, so entropy increases. Temperature of a solid is lowered. Now, when you lower that to 0 Kelvin, it becomes a perfect crystalline solid. And as per the third law of thermodynamics, entropy of a perfect crystalline solid is always 0. So here the entropy decreases. Sodium bicarbonate solid becomes sodium carbonate, CO2 and gas. So here there's CO2 and steam it forms. So more amount of gaseous product. So here also entropy increases. And the last one, chlorine gas splits up to form two free radical chlorine atoms. That is the gaseous free radicals. Here also the entropy increases. So it's A, C, and D where it increases. That's option 2. So 57 is 2. That's the 57th one. Next comes 58th one. All right. Aniline does not undergo Friedel-Crafts alkylation reaction. Yes, that's a correct statement. And aniline cannot be prepared by Gabriel's phthalimide synthesis. That is also true. So both are correct statement. So it's option 4. Now why that is? Observe this. Aniline cannot undergo Friedel-Crafts. That's either alkylation or acylation due to a salt formation with the catalyst, which is the Lewis acid catalyst aluminum chloride. Hence, nitrogen acquires a positive charge and becomes a deactivating group. Deactivating, which makes the benzene ring less reactive. And aniline cannot be prepared by Gabriel's phthalimide because aryl halides generally undergo electrophilic substitution. They do not undergo nucleophilic substitution readily. And in this case, it cannot because with the anion formed with the phthalimide is there. That's why it cannot undergo Gabriel's phthalimide reaction. So 58th, that's the 4th one. Then the next one comes 59th one. They're asking over here. All right. Number of Faraday is required. Now, one simple trick with respect to Faraday, 1 mole of electron corresponds to 1 Faraday. Look at this. I have solved this part. 1 mole of electron is 1 Faraday. So if you have 1 mole of water, it will give half oxygen. One oxygen atom gains 2 electrons to form an oxide ion. So for one oxygen atom, is this clear? To completely form an oxide, it's going to be nothing. But here they have given already half O2 there. So that corresponds to 1F. MnO4 becomes Mn2 plus 7 becomes plus 2. So it gains 5 electrons. So 5 Faraday. Calcium chloride molten breaks to give you calcium plus chlorine. Calcium is divalent. So calcium ions to calcium will gain 2 electrons. So for 1.5 moles, it's going to be 3 Faraday. And the last part, iron oxide getting converted to Fe2O3, that is ferric oxide, plus 2 becomes plus 3. So there is change of 1, which means 1 electron. So hence it will be 1 Faraday, but there are 2 moles of Fe. So that will be multiplied by 2. So that's going to be 2 Faraday. So this part, if you observe, 59th, it's the first option. That's going to be nothing but the correct answer. Clear? Now next, which of the following is nothing but ln k versus 1 by t, which is with respect to the Arrhenius equation part. It's basically a negative slope. So there's only one. That's option 3. So 60 is the third one, where we know the slope is minus EA by R. 61st one. All right. The boiling point of 3-isomeric pentane follows N-pentane greater than iso greater than neo. That's true. When branching increases, it acquires a spherical shape. So the surface area becomes smaller, due to which the intermolecular forces between the molecules are weaker, and that lowers the boiling point. Correct. Both statements are right, because we know more the compound is in a straight chain like N-pentane, then the surface area is larger, greater is the magnitude of van der Waals forces, and hence greater would be the boiling point. As branching increases, surface area decreases, boiling point also decreases. So 61, that's nothing but the fourth part. Then 62 here, you have to match with respect to the different isomers. Have a look at this now. What does it say? 62nd one. The first one, that's a linkage isomer due to the due to the ligand. That is NO2 is an ambidentate ligand. So it can be written as ONO, that is the nitro-So group, or NO2, which is the nitro group. So that's linkage isomer. Second one is ionization, because you have sulfate and bromide. Sulfate is inside, bromide is outside, and vice versa. That's ionization isomer. Third one is coordination isomer, where you can exchange the ligands with respect to the metal ions. So in one place where it is ammonia, it can be exchanged with cyanide and vice versa. And the last one that we have, that's a solvate isomer. Why solvate? Because water molecule can be either a ligand also, as well as it can be outside as a solvent also. So here, if you observe for this one, 62, it's going to be the fourth one. Then next, 1 gram of sodium hydroxide. This is a very small, easy question with respect to the mole concept part. Answer here is A, 250 milligrams. How? Have a look at it. Normal neutralization reaction, what we have, NaOH and HCl gives us NaCl and water. Both are 1 mole. NaOH molar mass is 40 grams. HCl is 36.5 grams. Concentration C we know is N by V. So number of moles is concentration into volume. It is 0.75 molar into 25 ml. So I've taken 25 into 10 raised to minus 3, converted the ml to liters. So 0.0188 moles are required. This is of HCl. Now, as both are 1 mole reacting, NaOH also will be 0.0188 moles. Multiplied by 40, amount of NaOH consumed is 0.7250 grams. 1 has reacted, so left behind is 248.248 grams, which is 248 milligrams, approximated as 250 milligrams. That's the 63rd, the first one. Then, next one, 64. Which of the following alcohols reacts instantaneously with Lucas reagent? Now, with respect to alcohols, we all know the reactivity. Tertiary is more reactive, then secondary, then primary, then methyl. So here the answer is 3. Why? Because of the plus effect, branching is more, the bonds will break faster. It will give an immediate turbidity of alkyl chloride. Secondary gives after some time, and primary gives only on prolonged heating. That's the distinguishing test of alcohols with Lucas test. That's the 64th one. 65th one. Now, this was basically one of the solved questions, if anybody goes through it. This is given in the DNF block, the solved examples of NCERT. The standard electrode potential of Mn3 plus to Mn2 plus is more positive than chromium to or with respect to iron. It's because of, have a look at it. It's because of its third ionization enthalpy of Mn, where D5 is changing to D4. I've given the part, it's an in-text solved, so make sure, please go through the solved examples also, which are given of NCERT. 65th, that's the fourth one. Next one is intramolecular hydrogen bonding. Intramolecular hydrogen is in orthonitrophenol, and intermolecular hydrogen bonding is in paranitrophenol. Then next comes with respect to what we have. This is the chemical bonding, the shapes of the molecule as per VSEPR. Ammonia, that's a trigonal planar molecule. So look at this part, 67th one. Ammonia trigonal planar, BRF5 square pyramidal, XCF4 xenon tetrafluoride is square planar, and SF6 is a regular octahedral. So first three are as per VSEPR. Last one is a regular molecule. All right, 67 is the fourth one. Then 68, among group 16, element which does not show -2 oxidation state. Line of the NCERT, that element is polonium. The tendency of -2 oxidation state down the group decreases for group 16. So polonium hardly shows -2 oxidation state. 69th one, boiling point of hydrides is in the order water, H2T, H2SE, H2S. Yes, this answer is correct. On the basis of molar mass, water is expected to have lower boiling point. Now, this statement is false. In fact, water is a volatile liquid having a higher boiling point because of extensive hydrogen bonding. So here we will say in the 69th one, water has high boiling point and low volatility due to intermolecular hydrogen bonding. So first statement is right, second one is false. So 69th one is the second one. Then 70th one, spin only magnetic moment is the same for which of the ions? Now these questions are all picked up from the table. So if you see your DNF block, the spin magnetic moments are being given there where who is having the similar ones. So make it a point to see these tables also. That's very important. 70th one, if you see here 70th, Cr2 plus will be argon 3d4 and Fe2 plus will be argon 3d6. So both will have 4 unpaired electrons. In other words, both will have a same magnetic moment of 4.9 Bohr's magnetron. So 70th is 4. st one, the reagent with which glucose does not react. This is because it exists in a cyclical form also. So because of that, it doesn't react with. This is again a line which is given of the NCERT part. It doesn't react with 2,4-dinitrophenylhydrazine to give its 2,4-dinitrophenylhydrazone test, nor does it react with Skiff's reagent, that's para-rosa aniline hydrochloride, as well as it doesn't give the bisulfite precipitate because of the cyclic structure. So 71 is the second one. And statements are given below. Now, this is again both examples. These are given as per the VBT in coordination compounds. They've explained both the examples, and this is a paragraph on which the statements are there. So these are all the paragraphs which are given, as well as the entire examples are explained in NCERT. Hexaamine cobalt 3 as well as hexafluoride cobaltate 3, both over there. They are octahedral but different in magnetic behavior. CONH36 is diamagnetic, where the other one is paramagnetic. Yes. Look at this, what it says. For the 72 one, it's the fourth one. So both are correct statements. Only thing is CONH36 3 plus, that is hexaamine cobalt, Roman number 3 over there. This is nothing but a inner orbital complex or a low spin complex that undergoes D2sp3. All electrons are paired, hence it is diamagnetic. Whereas hexafluorocobaltate 3, that undergoes sp3d2, which means it is an outer orbital or a high spin complex, and it has unpaired electrons, so it is paramagnetic. So 72 is 4. Then the most stable carbocation. Now, stable carbocation comes with respect to hyperconjugation as well as resonance. So in this category, the most stable carbocation will be the third one here. Why? It's with respect to the alpha H. So on this side, this is alpha, this is alpha, this is alpha. So here we have 2 hydrogen. Here also we have 2 hydrogen. And on this one also there is 1 H, as well as here there is also 3. So 3, 4, 5. So you will be having 1, 2, sorry, in the between one there is no H because it's a positive charge there. Sorry. So you will have 3, 4, 5, 6, 7. So this has basically 7 alpha H, which means it will have 7 hyperconjugating structures. So third would be the most stable. So 73 is the third one. 74. Fehling solution A, that's nothing but over there what we have as aqueous copper sulfate. So here if you see 74 is 4, and Fehling solution B, that's Rochelle salt, alkaline solution of sodium potassium tartrate. So 74 is 4. 75, which of the following Kp and Kc are not same? Now A, B, C, the products and the reactants are the same. So Kp is equal to Kc. It's only the last part. Then 76, here you match the followings over there. So in this category, observe this. First one, an alkene is converted to a ketone. That's by ozonolysis. Second one, you have converted benzene into two benzene with a ketone. That's benzophenone. Matlab basically a benzoyl group is come. C6H5CO along with C6H5CO Cl. So this is Friedel-Crafts acylation, specifically benzoylation using benzoyl chloride. Third one, you are converting a cyclic alcohol into a cyclic ketone. So that's oxidation by using CrO3. And then the next one comes where we have alkyl benzene getting converted to its potassium salt, which is a part of oxidation of nothing but vigorous oxidation of alkyl benzene, what we call, where we say the alkyl benzene part, alkyl benzene, when you react with alkaline KMnO4, first it forms its potassium salt. Finally, whatever is the long chain, it gets completely degraded to carboxylic acid. That's the part. So if you observe here, your 76 is nothing but the second option. Then comes next. Compound of the formula C6H14 has two tertiary carbon. Two tertiary carbon is only one compound, is an easy one. 2,3 dimethyl butane. So that's the one. So 77 is this, 2,3 dimethyl butane. 78, activation of any chemical reaction can be calculated by. Now, chemical reaction is with respect to rate constants at different temperature. So 78 is 3. That's the Arrhenius equation formula, what we have. Then 79. On heating, some solid changes from solid to vapor without passing the liquid state. So this technique of purification of solid directly into gas, that's nothing but sublimation. Energy of an electron in the ground state N is 1 for He plus is minus X. This was an easy question, little tricky, but very easy. And that for electron in N is equal to 2 for B3 plus in joules will be. This will be the same, minus X only. How? See this part. What is the formula? Energy of electron in the nth orbit minus 2.18 into 10 raised to minus 19 joule into Z square upon N square. For He plus N is 1. So basically we have Z for helium is 2. So 2 square upon 1 square. So the ratio is 4:1. And for B3 plus, that's going to be nothing but minus 2.18 into 10 raised to minus 18. That's common. So that's cancelled. So if you take a ratio, B3 plus Z will be nothing but over there outermost shell. So Z atomic number is 4. So 4 square upon outermost shell is 2, 2 square. So 16 by 4, that also come as 4:1. So if both are 4:1, the value will remain the same. That's minus X joules only. So 80th is the fourth one. Now this is a very easy one, not a redox reaction. That's going to be the C1 because that's a double decomposition reaction. So 81 is 3. Next one, which of the following will bring about the following transformations? This was a good question. You have an alkene and finally the product formed is an aldehyde. Now alkene to aldehyde, that too in a straight chain. The first reaction is going to be nothing but hydroboration oxidation, where first you will react with diborane, boron hydride. That's its dimer B2H6, followed by formation of a trialkyl borane, which will further react with H2O2 in presence of an alkaline medium to give its respective primary alcohol. The reaction is a regioselective reaction, which is in line with anti-Markovnikov addition, giving you primary alcohols. And then it will be with PCC, where with PCC, primary alcohols can be selectively, primary and secondary alcohols can be selectively converted to respective aldehydes and ketones. So for the 82 one, '82 is the first option. So with BH3, first it forms its primary alcohol, where the OH gets attached to the carbon having more number of H atoms, which is the part of the double bond. And then with PCC, you will have the OH getting converted to alcohol. Remember, you can use PCC as well as PDC, pyridinium chlorochromate, pyridinium dichromate. Then next one, 83rd one. Now here, this is with respect to the shapes of the orbital. This was a very easy question of structure of an atom with respect to the 4 quantum numbers, where ML, that's going to be nothing but the magnetic quantum number that gives you the orientation of the orbital. MS is the spin, which tells you the orientation of the spin. L is the azimuthal quantum number, which tells you the shape of the orbital. And last is principal quantum number, which tells you the nothing but the size over there. That's one. So let's talk about it. What is it? So 83rd one. That's the first option. This was a good question. Many people have goofed up in this 84th one. They have given a reaction. Kc value is given to you. And at a temperature, they have given the concentrations of all the 3 equal. So many people thought if all the 3 concentrations are same, the reaction should be in equilibrium, but that's wrong. What is the part? You have to calculate QC first, then check. If you remember the terms, if QC is greater than Kc or QC is equal to Kc or QC, only if QC is equal to Kc, it's equilibrium. So first calculate QC, that is active mass of B into C, active mass of C upon active mass of A raised to 2. So look at this part. 84. There you are. You calculate QC. QC comes as 1. And Kc is 4 into 10 raised to minus 3, which means QC is greater than Kc. So if QC is more than Kc, the rate of backward reaction will happen. In other words, the products, the reaction has gone completely towards the products. Concentration of products will decrease, that of reactants will increase. This was a good one. So 84, it's the second one. All right. Then easy one, the highest number of helium atoms, if you see, that will be in 4 moles of helium, which will be 4 into Avogadro's number. All right. The next one, the pair of lanthanoid ions, which are diamagnetic. Diamagnetic, all electrons are paired. This is again from the table, which is given in the D and F block part, where in the lanthanide series, they have explained over there or given a table with respect to its oxidation states. Okay, how many unpaired electrons are there? There you are. Ce4 plus and Yb2 plus. Cerium 4 plus has a configuration of xenon 4f0 and ytterbium has xenon 4f14. So 4f0, 4f14, no unpaired electrons. So both are diamagnetic. 86 is 4. Then the next one, this was a very easy one from halogen derivatives. Alcohol plus PCl3 gives alkyl chloride plus a byproduct H3PO3. And alcohols plus PCl5 gives RCl plus HCl plus POCl3. So it's H3PO3 and POCl3. That's option 3. So 87 is the third one. All right. Next comes 88. The first one, hexaamine cobalt, Roman number 3 is a homoleptic. Yes, because it has only one type of ligand, that is ammonia. And CONH34Cl2, that is tetraamine dichloro cobalt 3 over there. That's heteroleptic because there are 2 ligands. You have ammonia as well as chlorine. So this is a correct statement. Complex has only one kind of ligand, but the other one has 2 kinds. Yes, this is also true. So basically both statements are right. All right. Next one. Iodide reacting with cyanide. So replace the I by cyanide. So you have CH3, CH2, CH2, Cl. Then it says OH partial hydrolysis. This is again a good part. This is basically preparation of carboxylic acids. Cyanides undergo acid as well as alkaline hydrolysis. In alkaline hydrolysis, if you do partially, then the intermediate product formed is amide. So the product formed here, the B1 will be CH3, CH2, again CH2, and C double bond O, NH2. So it's basically addition of water. So CN becomes CONH2. So here, if you observe the part, it is the cyanide becoming CONH2. And then it says NaOH and bromine. Now, NaOH and bromine is nothing but Hoffman's bromamide reaction, degradation. Carbon atom decreases by 1. So if the carbon atom changes by 1 over there, what will we get? CH3, CH2, again a CH2, and NH2. That's N-propylamine. Option is 4. Clear? So look at this. That's the 89th one. Partial hydrolysis, cyanide becomes CONH2. That's an amide group. So 89 is 4. All right. 90th one. The work done during reversible isothermal expansion. Isothermal reversible process, that's going to be nothing but Wmax. For 1 mole of hydrogen, pressure of 20 atmospheres to 10 atmospheres, R value is given in terms of calories. This is a direct, easy calculation. Answer is A. 90th one. See that. Isothermal reversible. So Wmax is minus 2.303 nRT log of P1 by P2. So that calculation comes as minus 413.149 calories. So 90 is the first one. Then 91st one, select the correct one. BF3 is non-polar. BF3 has non-zero dipole moment. No, BF3 has zero dipole moment. Again, this is given in chemical bonding. If you observe under the concept of dipole moment part, because BF3 is trigonal planar. The sum of any two dipoles will be equal and opposite to the third one. So this is a false statement. Then dipole moment of NF3 is greater than ammonia. Again, false, because the orbital dipole of ammonia is in the same direction, whereas NF3 is in the opposite direction. So ammonia, in fact, has a greater dipole than NF3. Canonical forms of carbonate ions are 3. Yes, this is the correct statement. That's the answer. And 3 resonating structure. Now, this is a very tricky one. If anybody sees ozone structure given over there in your P block part, or in your, what you can call, it's also given in the chemical bonding part and the resonance. They have given 3 structures. 2 are resonating. 1 is the resonance hybrid. So 3 resonance structure is also false. The number of structures are only 2. Resonance hybrid is not one of the resonating structure. We all know resonance hybrid is the hypothetical structure. So 91 is 3. That's 91. 92 now. 92, KMNO4, and it's given with H plus. If anybody remembers, this is basically an alkene. Alkene with KMNO4, we have 2 reactions. If it is cold aqueous KMNO4, then that is formation of glycols, what we have in the 11th standard, Bayer's test. But if it is KMNO4 in presence of H plus, then it's oxidation, where the double bond breaks and the final product is carboxylic acid. So here the double bond will break and you will have formation of acid. So 92 is first one. All right. Then 93rd one, this is from the practicals part what we have. During preparation of Morse salt is what we also call as FAS, ferrous ammonium sulfate. Which of the following acid is added to prevent the hydrolysis of ferrous ions? It's going to be dilute sulfuric acid, because Morse salt, we add nothing but ferrous sulfate and ammonium sulfate in its aqueous solution, where generally dilute H2SO4 is added to prevent the hydrolysis because sulfate ions, that would be its common ion effect. That's the part. This is in the volumetric analysis. Next question is also on the same volumetric analysis what you have. The qualitative analysis, arrange them in the increasing order. Now you need to know which cations precipitate in which group. This is also a part of the solubility and solubility product, where we say in the qualitative analysis, all the cations are arranged in the increasing order of their KSP values. So if you see aluminum, that precipitates in group 3A of the cation analysis. Calcium, that precipitates in nothing but group calcium ions, right? Calcium precipitates in group 4. Barium ions are also group 4. Yeah, there's a mistake actually. It's not calcium. If I'm not wrong, it's copper. It's a mistake there. This part is cupric. So copper precipitates in group 2. Barium precipitates in group 4. Cobalt, that precipitates in group 3B because group 3 has group 3 and 3B. And magnesium precipitates in group 5. So the increasing order, lower to higher. So if you see the 94th one, that's the fourth option. Aluminium 3A, cupric 2, barium 4, cobalt 3B, and magnesium group 5. So 94 is the fourth one. 95. Now this was a good question. It linked two parts. It linked a little bit of the kinetics also, as well as with respect to the alpha. All right, this was really a good question. Little longer to calculate, but it was a good one. Look at this, 95th one. First, you can calculate Kc by the formula. Active mass of product upon reactant. They have given the values of the concentration of nitrogen, oxygen, and nitric oxide. So Kc comes to first part, 1.6. Now you substitute and get the formula for Kc, which in terms of alpha comes as alpha square upon 4 into 1 minus alpha square. So that if you equate, alpha value comes as 0.717. That's the 95th one, the third one. Then mass of copper deposited by passing so many amperes containing copper sulfate. Copper sulfate meaning CuSO4, copper oxidation status +2. There's a very direct question and you will get the answer. This answer comes as 0.315 grams. See here. By the formula, Faraday's first law, W is equal to ZIT. Z is ECE, can be also written as E by F. So E is the equivalent mass. Since it is copper sulfate, equivalent mass of copper will be 63 by 2, which is 31.5. So small e is 31.5. Current in amperes is given. Time t is seconds. And Faraday is 96,500. So that comes as 0.3150 grams. So 96 is the first one. 97th is also an easy one. Plot of osmotic pressure versus concentration gives a straight line with a slope. Now you want the temperature at which this experiment is done. There's an easy one. This temperature comes to 37 degrees. See there. If you plot the graph of pi versus c, it's a straight line. So pi is your y-axis, c is your x-axis. So basically the formula straight line, y is equal to mx. So slope m is nothing but your RT part. So T will be slope upon R. That comes as 310 Kelvin. Convert the Kelvin into the Celsius scale over there. So that comes as 37. So 97, that's the fourth one. 98, the major product. This was a very easy. With PBr3, the first product it will form will be here. OH will be replaced by Br. The methyl group will be as it is. Then with alcoholic QH, it's beta elimination. So with beta elimination, you will have a situation here. Look at this. That's your alpha. That's your beta. That's your beta. Now on this, if you observe, here there are two H. And here there is only one H. So that's why if you catch the word major, people Sadzav's rule, Sattu's elimination. H is removed from the beta carbon having least number of H atoms. So if it moves there, then the product formed here would be nothing but the methyl group will stay as it is. A double bond will come here. That will be a major product. All right. And that's, if you observe, that's nothing but option 4. So 98, that's option 4. It's nothing but a concept of Sadzav's rule. That's 98. Second last one, 99th one. Rate of a reaction quadruples when temperature increases from 27 to 57. Calculate activation energy. And they have given you log of 4 over there. It's a direct, easy calculation. Look at this. 99th one. Log K2 by K1 is EA upon 2.303 R into T2 minus T1 into T1 into T2. So if you substitute log 4, that's 0.6021. EA into R, I've converted the R from joules to kilojoules because all the 4 options are in kilojoules. So that's 8.314 into 10 raised to minus 3 and the temperature part. So that comes as 38.04 kilojoules per mole. So 99 is 4. And the last one, compound has 32% A, 20% B, and the rest is C. So this is basically nothing but 52. So C has to be 48. They have given the atomic mass. So divide the percent by the atomic mass, get the simple ratio. If all are not in whole numbers, multiply all by a number to convert it into the nearest whole number. That would be your empirical formula. So see there. A 32%, so 32 by 64, that's 0.4. B is 20%, atomic its mass was given as 40. So 20 by 40, that's 0.5. And remaining is C. So that's 48 by 32, which is 1.5. So multiply all with 2. So all get converted to the nearest whole number. So that's the simplest part. That's AB C3. All right. All right, everyone. Thank you.